Good afternoon, everybody. My name is Alan Hoare from TU Dublin and the Construction IT Alliance. You're very welcome to CITA's Tech Trend Series 2021. This is the third of our 10-part series that's looking at, I suppose, the top 10 technologies that will transform the construction sector. And today we're looking at IoT and sensor technologies and the application of these technologies in construction. So just to welcome our speakers this afternoon, we've Natalia Pinkowska from Evercam, Casper Harlev from Sensohive, and Roef from TNO. So we've got from speakers from Poland, from Denmark, and from the Netherlands this afternoon. So you're all very welcome, and thank you for taking the time to join us. So our program will, as you can see, is laid out there. So we're hoping to finish at 2 p.m. So we might just have a mention our sponsors of the program. So could we go to slide 2, please? Suzanne, can you? Yeah. So we'd just like to thank our sponsors, Arab, Diatech, Murphy Geospatial, RIB, I2, Costex, Solibri, and Evercam, Lionside, and SIS. We wouldn't really be able to put these events on without your support. So thank you to all these great innovative companies. I did mention this is a 10-part series. So we've already looked at sort of cloud-based project construction management, BIM innovations, and now we're looking, as I say, today at IoT and sensor technologies. We'll be moving on later next month to look at drones, digital twins, e-commerce, robotics, AR, VR, 3D printing, and robotics. So some really exciting events coming up and a lot of interest. So just to complete then, we have another, just to mention our circular economy event next week. We continue with that agenda by looking at exploring the role of planning authorities as catalysts in transitioning towards circular economy. That's on the 6th of May. So we're delighted to have speakers from Northern Ireland and in the UK to update us on how local authorities are driving the sustainability agenda. And also just to, Suzanne, if you go to the next slide, it's just to encourage you all to stay, connected with CITA through the various social media channels and so forth. So, and thank you again to the CITA team for all their hard work in putting these events together. So Natalia, good afternoon.
Hello, good afternoon, everyone.
So Natalia, if you'd like to start when you can.
Yes, of course.
Thank you very much.
Let me share my presentation.
So just to say to everyone, if you have any questions, you can pop them into the chat facility. I'll keep an eye on those during the presentations. Thank you.
Okay. Hello, everyone. My name is Natalia Pinkowska. I work for Evercam in Dublin as a research manager for the company. As Alan mentioned, I am based in Poland. We are actually a fully remote company, so we have people and teams spread around the world these days. We all work for the Dublin-based center. I would like to talk today about our camera system, about our construction cameras, and how we integrate various other technologies into it. Since I am the first to speak, I'm sure that you are aware of all the nicks and knacks of construction and the technology that's available here, but I will give you a little bit of an overview first. So as you sure know, construction is one of the greatest, biggest industries in the European Union. And you might not know that it contributes directly to 9% of the European Union's GDP, and that 18 million people are employed in this sector. Therefore, there's surely is a great market for technical and technological companies to develop and offer new innovations. So the problem with with the construction is that little revenue is reinvested in R&D and in all digital transformation tools. This might be due to the fact that there are certain ways in which we have all been working for a long time. We are risk averse. We want to make sure that the job is done. But it is not really efficient. I'm afraid that from the little revenue that the construction companies are making and the small margins that are there, as much as 5% of revenue is lost on rework. So there is unfortunately a lot of waste and a lot of potential to fight this waste. As we are mentioning, it is estimated that delays might cost 1.5 billion per year globally. Now, as we are watching in the manufacturing sector right now, manufacturing is moving into Industry 4.0. Industry 4.0 is about machines talking to each other. It's about automation. It's about robotics. It's about eliminating all possible human errors from the process and producing something as repeatable as possible. Now, the question is construction 4.0 possible? Is the digital transformation going into this direction? I think it is significantly more complicated in the construction world. We have too many factors that can go out of hand. Also, each construction site is different. In the manufacturing world, we have the repeatability of the products and the controlled, closed environment. Here, we are talking about the disruptions from inside and outside the construction site. Therefore, there are quite a few chances that need to be taken. Now, if you look at this slightly joking slide, you can see that early on we were talking about in advance planning, 2D drawings, and a lot of potential for errors and misunderstandings. Seeing this, the construction sector has moved into the world of BIM, of detailed planning, of schedules and project management. Unfortunately, even with 3D pictures, we are still working in the realm of imagination. And every person, even seeing the drawing as it is, the 3D render and the visualization, they might put it in reality a bit different. Therefore, there is still a lot of potential for errors and delays. What we are moving towards these days is drawing real-time data and having common environments for our technologies so as to see the progress and the situation on the construction site as clear as possible. Now, in order to see the reality, the best way to capture the big picture, the best way to capture the reality are construction cameras. There are different technologies available. So there are these fixed position cameras. There are all kinds of drone technologies that, as I hear from Alan, you'll be also talking about in the nearest presentations. There are also these 360 degrees cameras where you have all kinds of workarounds and to register the current state of play. We at Evercam, we are focusing on the fixed position cameras. So we locate 1, 2, sometimes more cameras around the construction site in order to continuously record what's happening in there. And this recording is then stored in the cloud, and we put quite a few interesting tools on the videos so that you can see your project better. Now, why are we doing this? What is our driving force? We believe that when people have clearer visibility of the project, they can also communicate better and with better communication, we have better progress, better productivity on the construction site. So what does productivity mean? It means something else for each role on the site. So we have the project manager who wants to know what the progress is, what the current progress is. We have the quantity surveyor who wants to know what is delivered and when. We have the health and safety engineer who is interested about reducing the accidents, and if they happen, to resolve the issues as quickly and as efficiently as possible. We have all kinds of roles and all kinds of aspects of the projects where productivity is affected, and with clearer visibility of what's happening, each of these roles increase their section of productivity. Now, so the functions that we offer at Evercam, I will slide through them quite quickly. I believe that our brilliant salespeople are much better at presenting these functions, but I would like you to know a little more about what the product can do, what our service is. So first of all, you have the live view, meaning you can constantly look at your construction site. You can at any moment have a look of what is happening at this very point in time. We record everything and we store it in a secure cloud service throughout the project. So if we install the cameras on day one of your project, you will have full documentation up until the moment that the cameras are on your project. You can retrieve any given time, any given moment, at any point desired. So our main product is the marketing tool of time-lapse. Many developers and many contractors want to have these beautiful time-lapse pictures that they can post around, that they can show their neighbors, that they can show to their customers, showing how the work is progressing. We are quite efficient and proficient at producing these time-lapse videos, and the dashboard also allows you to download them yourselves. There is this beautiful compare tool that shows you two chosen moments in time. You can, again, use this as a marketing tool or for project managers to compare the work done, for instance, in a week. There is a super zoom. Our camera. The most common cameras that we use these days are 12 megapixel cameras, so you can imagine that the resolution is quite high and you can zoom in quite efficiently as well. There is a nice tool for editing the pictures directly in the dashboard, marking issues or marking things to be done, and you can share these pictures easily with your subcontractors and with your team to as if support what you're asking them to do with a visual proof, with a comment. X-ray is like a compare tool, but on a smaller area. In this way, you can look around the site and have a look, for instance, what's behind the wall, what's behind your facade, what's behind the pillar, because this was built, for instance, a week or 2 weeks ago, and you can have a look what was there done before. Sharing is very easy. You can add an unlimited number of users with just inputting their email. And you can also schedule regular updates about your project by sending yourselves regular snapshots, pictures of the site. We are integrated in some popular construction software, so that, for instance, if you use Autodesk on your site, you can swiftly send a picture from Evercam to your Autodesk suite in order to confirm certain events or document progress. Now, there are some additional features that we are especially proud about. We have introduced the visualization of your BIM model so that you can see it integrated in the picture as one of the layers. It can be turned on and turned off, and in this way you can see what the progress is, where you are, how far you can go, and also by inputting the BIM model into the actual camera picture, you can market your project further. With this is connected a measuring tool, so it's a tape, a kind of a virtual measuring tape where you, on one of the planes, you can measure the length of certain objects or areas. You can, for instance, with this, you can estimate the cost of piping, the length of the perimeter of your of certain area that you need to seal off with some kind of a wall. This is of course only as accurate as it goes in this resolution and with this kind of marking, but our customers report that it is quite useful for orientation and estimation. Now, we have introduced the tools based on machine learning and artificial intelligence into our dashboard as well. And the first product based on automated recognition of vehicles on site is our gate report. This is an automated report which shows all entries and exits from the site. This can be, these entries and exits can be divided by the type of truck that you want, and can be used, for instance, by the quantity surveyor to check the invoices that they have received from a certain subcontractor. Now, just a few use cases to show you how these features are applied. So, all kinds of health and safety incidents happen. Unfortunately, it's not like we can prevent them just now. But if they happen and when they happen, we know that they can be resolved much quicker if you have a visual proof of what's happened. You can find out who's left this machine here. You can understand who was at fault, and you can also see, you can also make your claims with the insurer much faster. Now, we have one of our customers has a storage yard, which here is shown quite beautifully covered in snow, where they have a process on which they want to make sure not only as how many trucks enter and leave the site, what machinery is there parked or moving around. They would also like to make sure that each of these trucks goes on the weighbridge and doesn't miss the weighbridge while arriving with aggregate. We are helping them develop an automated report just for this purpose. Now, another use case is for monitoring energy use. A very simple solution to make sure that the lights are off when they should be off. You can send yourself a snap mail at an hour where the construction should shut down, and every day you'll receive a picture proving whether the lights were off or on. These are all small improvements, but if you add them up, the savings are substantial. Now, what's ahead for us? What we call it is construction visualization. Now, I'm saying that we want to integrate sensors into the camera picture. Now, the question is, why even integrate? Why can't we just have what we have? Well, it's not sustainable anymore. We have devices, all kinds of devices. We want to work from home. We want to work from the office. We have to work from the construction site very often. Each of these environments requires a different device from us, so we need to have everything available at hand on each of the devices. Now, the question is, how many apps can you have on this device? How many tools can you carry around? Even if they are the smartest, if they only do one thing, it means that every time you will have to ride around with a truck to carry it all. These days we can make use of all the rich data that is collected on the construction site. We have the potential of machine learning, we have the potential of AI. Now, if we don't integrate the data from the different sources, the AI is useless. It can only work on the data that is delivered without the integration, without looking at the site holistically. We are unable to leverage this potential. Now, this brings us to a kind of a platform approach, and it has been confirmed by research and by looking at what companies want, that like the platforms have overtaken many parts of our life these days. They surely also should make way towards the construction business, and this is our nearest future. Therefore, at Evercam, we have started looking at this integration potential. And the first thing that we suggested, that we proposed, was integration with additional ANPR cameras. ANPR stands for Automated Number Plate Reading, which means that there are automated off-the-shelf cameras that can simply read and register the number plates of every vehicle entering your site, leaving your site, however you set it up. Now, what we can do is integrate the ANPR reading with the gate report. So we can both see the vehicles entering and leaving the site and match it with the appropriate number plate reading. So in this way, we do not only recognize the type of the vehicle, we also see we also identify the very vehicle that came on our site, and can then look into the recordings to verify if they delivered what they promised, if they behaved in a manner that we have obliged them to, if they have stuck to health and safety requirements. Another integration, very recent on our platform, is weather. By clicking at any given time, by clicking an icon for weather, we can see what's happening at this point. So we can have an orientation, not just on the site, but also from far away, whether this is a good moment to pour your concrete, or how long you can expect it to dry. Also, if our subcontractor told us, okay, 3 days ago I wasn't able to do this and that because the rain was pouring the whole day, you can easily verify this and document it both with the picture and with the data weather data integrated here. So we are going further this way to integrate more and more. But what is also important is that we want the data visualized in the camera. So in this way, we do not just look straight at what's happening. Where we want to arrive is that you have an all-around view of the site, just as if you had a constant drone footage, constant transmission from the drone, from your fixed position cameras. This is definitely where we are headed in the nearest years and months. And where we would like to arrive at is a kind of a Google Earth experience for construction. So whatever you click, wherever you arrive, you can see more details. Yeah? In this way, you can see how much of the structure is completed, what objects are on the site, and how they are counted. Whether the machinery is operating, whether it has all the permits that are required. You can also detect breaches. You can see risks that are out there, and you can see areas that are closed or will be closed. This is our ambition for the nearest time, and for this purpose, we have entered into a DTIF project together with TU Dublin and our the other enterprise partner, Gagamuller. Together, we will be trying to deliver this. We will be working the next 3 years to deliver this experience of all-around visualization, but also of integration with various sensors on the site. Some of the sensors that Gagamuller is delivering will be mounted on the helmets to track the users, but not they will be impersonalized. Therefore, we will stick to all the requirements of the Personal Data Protection Act. So we are quite excited to embark on this project. We are very happy that the government has just decided to co-found it, and we will be working on this the nearest 3 years. Thank you very much. This is all that I wanted to share today. And of course, if there are any questions, I'll be happy to answer.
Thank you, Natalia. Yeah, I wasn't aware that there was such versatility in the technology that you presented. Such a rate, and presumably you're adding functionality to it all the time. I know there was a comment there from Rob just about the reference to capturing car registrations and whether this would be permitted in other jurisdictions. Rob, did you want to maybe elaborate on that?
Well, I know that privacy is a thing, and I'm pretty sure that in the Netherlands you're not allowed to film, even on your own site, personal things like license plates and those kind of things. I don't know how you're dealing with that. Do you need a written approval? Mm-hmm.
So the main assumption here is that we are working under the GDPR, the common EU framework. The main assumptions are that you need to have a reason to register, and that you need to mark the site clearly that everything is recorded. So this we are doing. We are giving advice also to our customers how to mark the site properly. When it comes to personal features, from this angle at this resolution, we do not really feel people in a way that you can recognize their feature. We are not doing any facial recognition. We are not performing any personal tracking. We are just looking at the machinery and at the objects. And since these are commercial enterprises, there is a reason to record both from the health and safety and from security purposes. So yes, it is permitted. Of course, it may differ from jurisdiction to jurisdiction, but as we are present both in Europe, in European Union, in the UK, and now we are also in Australia and in the United States, we see that all around this is a standard practice on construction sites.
Okay, thank you. Thank you, Natalia. I see Vinny. If you do you want to come in there? I see your camera's on, or are you?
Hi, Alan. Thanks, Natalia.
Thanks, Natalia. Yeah.
Yes, the assumption we're working on there, the gate report in itself isn't tracking license plates on its own. That's if the customer wants to set up separately the ANPR, and that's what a lot of existing customers use, where they corral vehicles into a site and they would have an agreement with their suppliers. Okay, all of the trucks from a certain supplier, we are going to get an invoice for 20, and we want to match 20 with the license plates. What we've learned from chatting to the customers is that that's not always sufficient, and it also doesn't tell you if the truck was full or empty, and what the gate report does then in place of that is it says, okay, that is a tipping truck. It arrived empty at exactly this time and it left full at exactly this time. And I don't need to know the registration. Now, I can tell by the color and the livery what brand it is, but also what I need to know is if my invoice at the end of the month says 82 trucks are being invoiced for, that I've got 82 corresponding clips and images of those trucks leaving the site. And that data, you're allowed to keep that in the same sense that you would have been keeping it with pen and paper or with pictures, with dockets. And just incidentally so yes, it'll be that would be separate to the ANPR data, which would be agreed with the suppliers to be kept. And separate to that, we have encountered other jurisdictions where we were told that based on union rules and local labor laws that humans can't be recorded while at work. So luckily, we have a very smart team of programmers, and they designed a system which extracts the humans from the images.
Oh, wow.
Everything that is a human, we take them out of the picture, but we can continue to record the progress. So we can also we have had clients who insisted on having videos where a customer or a client or nobody could come and pause the video and see, okay, that's not done exactly as it's supposed to be, or that's an issue or whatever. So we can make a video where there are no people and it shows a nice flow of progress without leaving anything individually visible. And also when it comes to having a site that's next door to a school or a public car park or anything, we draw a privacy shield, a big black box around that site, and it doesn't appear anywhere. And then in the final video, we take one frame with no people in it and superimpose it to make it look good. So every considerable GDPR question, we have usually had to tackle it, and in between. Different
How do the cameras deal with night vision?
Well, the cameras are great with night vision, but it's important to remember that not that many people work in the dark. Like they're not there to be a CCTV system. So when we have a lot of sites that work around the clock, and if there's any sort of ambient lighting at all, they will pick it up. But it's also a case that if you are working on a site at night, you're going to have decent lighting, and we're going to see everything that goes on.
No, just one of the comments I was put into the chat was, I'm assuming by default, the technology is a security.
Now, yeah, what's interesting there
it's not CCTV, I know. But
by default, the hardware is security.
Yeah.
But everything Evercam does is about productivity and dispute resolution and avoidance. And a good way for us to talk about it is, if you have a site, your CCTV system does its best work when the site is closed and it looks at the perimeter and it makes sure you don't get robbed. And lots of people will do that. We do our best work when we're looking at the middle and the gate, and we're doing our best work when the site is open.
Okay, that's great. Well, thank you very much, Natalia. And there was another comment in there about the fact that you're monitoring health and safety and, maybe identifying trip hazards and things like that. That's also in there, isn't it?
when it comes to the hazards, that's what we are what we are working on this requires predictive analytics.
And we'll be looking at that in AI as well.
We are working in this direction.
Yeah. Okay. Well, thank you very much, Natalia. You gave a great overview of, I suppose, a technology that's continuing to develop. I'm just wondering, how close is this technology to digital twins, or the fact that you're capturing this information on site, is that effectively a twin? It's interesting to see the crossover there. So thank you very much. So our second speaker,
thank you,
Casper, you're very welcome.
Hey, and thank you for inviting me.
No, very good. It's great to have you. And you're going to be talking about how to reduce carbon footprint and save project time with wireless concrete sensors.
Yeah. I think we're especially focused on the carbon footprint. I think we see a huge interest, like month over month, a growing interest in the carbon footprint reduction from like all construction companies, from cement manufacturers to general contractors, ready-mix suppliers, and so on. It's a huge focus right now all over the globe.
Wow. So saying that all over the globe, you're working in so many different geographic locations. So if you'd like to share your slides with us, you can talk us through your presentation. Thank you.
Cool. I'll present my presentation here. Whoops. I hope you can see my presentation.
Good to go.
So my name is Casper. I'm a co-founder and managing director of Sensohive Technologies. We are a technology company based in Denmark. Let me see, yes. I'll briefly, 2 minutes about us and a bit about our background and company and product and so on. And then I'll mainly talk about this carbon footprint reduction, also some time issues, in like 4 examples on how our clients are using sensors to work. We are necessarily not the answer on everything, but at least how sensors maybe are a part of the equation of helping the reduction of the CO2 footprint. So basically what we do is that we embed wireless sensors in the concrete. We transfer that data in real time to the cloud, where we do analytics on the data, on the curing and drying process of the concrete. And thereby in general, we help general contractors reducing project time. We know there's like full data transparency, so they know exactly what is the current state of our concrete, and they know exactly, and we do also predictions, so they know, also before it happens, when do they have the certain strength or certain relative humidity in the concrete in order to continue a process. And also, for example, there's always a lot of challenges in managing temperatures. If it's for example, too high differences in the concrete, you can have risk of cracks and so on. So that's basically what we help our clients with. And it looks like this, where we measure in the concrete and transmit data wireless and remote, often with a data transmission of maybe 10 minutes from the concrete. We launched the solution for job sites in 2019, January 2019. And in 2 years, we were at more than 750 projects. Now we are getting closer to 1,000 projects now, a couple of months later. And we have also gained a lot of interest from many big clients, such as you can see some of them below: Serneke, Skanska, NCC, Bessex, Sasir, a lot of the also Norwegian contractors. We do also have activities in Ireland, especially with one client or one partner, Matest, who's doing a lot of concrete testing in Ireland on many big constructions. And here are some examples. So, our products is mostly used on big concrete structures. So, bridges, high rises, precasting, tunnels, big foundations, mass pures, and so on. That's, that's where you have the biggest problems and you have a lot of uncertainties, and where you want to measure with sensors. So this is where we are primarily used. So I brought in, I think actually I had a fifth, as I said before in the beginning, but different ways that our clients are working with sensors to reduce the carbon footprint. So this is about the cement content. It's about automatic adjustment of heating and dehumidifiers. It's about the reduction of use of concrete cubes, specimens, which is often done. A huge things right now is also in many countries you are implementing green concrete or low carbon concrete, where parts of the cement has been replaced. And also a new thing, a lot of companies and also, building owners and municipalities and, are looking into is to extend the structure, concrete structure for a longer time. And that, basically is also about, reducing carbon footprint because you avoid casting new concretes. But I'll try to be quick. I know time is running fast. I think this was just an interesting chart. It's I know it's in Denmark, but the chart on the right is new here from a couple of months old, where the Danish government did analysis of the largest CO2 footprint companies in Denmark. And as you can see, we have one cement manufacturer, Aalborg Portland, which is counting for a huge amount, more than the remaining 9 in our top 10 in Denmark. So I think that at least tells a lot about the CO2 footprint when it comes to the cement, and it often counts 7 to 15% of the concrete is the cement. What we often see and where the biggest gains is that you have you have some targets you have to reach right in time. So maybe in 5 hours or in 12 hours you have to reach 5 MPa. In 4 days, you maybe need 25 MPa and so on. But what we often see is that because it's, let's say, quite not transparent in what is strength do we have in our concrete, then it's often over-designed and over-engineered by both the engineers and the ready-mix supplier. That maybe the contractor needed 25 MPa, but just to be sure everyone is taking their safety margins, and we're actually ending up with a much higher strength than we need. And the same on the precast, where you have very fast demolding, you also have often huge cement content in your concrete. So by what our clients gain a lot, especially when they start using sensors, is that when they embed, they get a full visibility or transparency of what is actually our current strength when we need it. And thereby they start learning, okay, can we go maybe a bit closer to our safety margins, or this closer to the target without risking anything. So this is one big help, where the sensor gives a lot of help from if you didn't had any sensors, you didn't have any visible curves, you just know that after maybe 28 days you will reach some kind of at least above the 35 MPa you need. And the same on the concrete mix. On the precast side, we combine climate sensor, the curing temperature, the concrete temperature, into integrating with heating, and then taking all these factors into account and see how can we actually design a concrete mix that makes sense. You still reach your cycles, production cycles, and you don't risk any even in the winter time when it's cold, you are not risking anything. For doing an early formwork removal, and what we often see is that we are very far. This could be concrete curing time on different elements you are casting. Right, you have maybe a 10-hour cycle, but your castings in the summer might reach its target strength after only a few hours. So what we help is to say, hey, you do actually have a lot of safety margins on top. Let's try to utilize that to reduce the cement content in your concrete mixes, and going slightly closer, but still without risking anything. The same with some of these new low carbon concretes is that we can see that many of them might have slightly higher curing times, but they still might be within your required maybe a 10-hour production cycle. So this is some of the ways we see clients are gaining when it comes to the concrete mix design. Then we also see a huge interest both on job sites but also on precasters to control the heating. So in many projects, you actually do heat up either the air around the concrete, or if you're on a precast, you are heating the concrete from the concrete beds, where we have done a project recently, a demonstration project where we started controlling this heating. So our data is gathered, and then implemented with PLC controls, so we can actually start controlling the heating. And what we can see is that on the precast side where we did it, that the heating they did, here with the gray, they have their curing time, and they might start heating one full day. They might heat too early or too late, or especially that they reach the target strength, but they still keep heating because it's just run after a standard template of heating template that they from 6 a.m. to 6 p.m. they just heat their beds, or from Monday morning to Friday night they just keep heating their concrete beds. So what becomes extremely visible for our clients is that, hey, okay, we might need to start a few hours before with some preheating, and then at least when we reach our curing time or our current strength, concrete strength, we can cut off the heating, and because we have reached the target strength we need, so all the remaining time is just waste of heating. And this way we can, on some of the first demonstration practice, we have shown heating savings around 20 to 25%. And when your total heating bill is more than €1 million, I mean, it's actually something you both can count on the CO2 footprint, but definitely also on your energy bill. Our goal of making these control heatings is, of course, to say, hey, okay, we have the temperature predictions of your concrete. And if we know that 6 a.m. in the morning you just have to reach the 25 MPa, then we can maybe start controlling the heating and maybe stop it even before we reach our target strength. So this is our goal of our work with the sensors and some AI engines. Yeah, so really about predicting, saying, hey, your target time is 5:45, your target strength is 25 MPa. And we know with the current heating and the current energy in the concrete that you will easily do that in time. So there's no need for more heating in your concrete. Yeah, here are some examples on some of the predictions we do. Yeah, I don't think this, but here's an example where I can see the production time every day. Here you can see how they actually heat it. And if we just cut off saying, hey, the time outside of the production you actually don't need to heat, then 60% in this case of the heating was done when you didn't do any castings, and 40% were actually done when you did the casting. So this is some of the stuff where we are working with our clients, is to help reduce these consumptions. Also, one very simple way is that many precasters, they work from Monday to Friday, and then the first people arrives again Monday morning, and one very simple way we have also been reducing cement content is to why not reduce the cement content on the Friday concretes? I mean, you have 48 hours to cure a concrete. You don't need a concrete that cures in 5 hours. So actually, 1 out of 5 days, you might actually be able to reduce the cement content a lot. So this is it's very simple, very easy way to gain. I mean, if you have the time, why don't you use it? Yeah. Also, that's both on job sites and also on precast. We do see many clients who want to reduce the usage of these specimens, either as cubes or as cylinders. That there's actually a lot of specimens casted, and it's both waste of resources and time and concrete. It's often held to work with these specimens. You have to store them under controlled area, like conditions, and you have to remember to go and press them in a certain time. And we believe that it's much more efficient to just embed a small sensor instead. And yeah, I think I mentioned it in one of the slides, but I found this picture where we can see that many of the new low carbon concretes, they are actually a bit more brown compared to the gray concrete. That there's a lot of uncertainties for many of our clients, both precaster and contractors, to start using these new low carbon concrete types. And contractors are asked by the owner, hey, or are required by the the owner or the to use these new types of concrete, but they actually don't know if it's the same cycle, is it the same curing time as we were used to, or is it longer, and how much longer, and how does that fit into our whole planning? So many of our precast or our contractors are using sensors to document or learning about the new type of concretes. And then the last part where I see a huge grown in interest with sensors is also the structural health monitoring. Here's one example of the largest bridge in Denmark, where they have actually recently reported that with use of sensors, drones, AI, and so on, mostly drones on the outside, and then sensors indoor or inside, you can actually walk inside this bridge. And of course, you can't fly with drones inside that, but at least you can put up sensors. That they have actually extended the lifetime of that concrete structure from expected 100 years lifetime to 200 years. I mean, that's a huge saving on new concretes to be casted, right? If you can save such a structure for such a long time. So like an indirect reduction of carbon footprint with reduction of new concrete casted. Yeah, I think that was the short, relatively short, I think made it in the 15 minutes presentation of at least how we or our clients are working with reducing carbon footprint and speeding up some projects with the
very interesting, yeah. The reference to SHM leads very nicely into Rob's presentation, I'm assuming, that we will hear from Rob in a minute. Yeah, I put a comment in the chat many years ago as a young, I suppose, engineer. One of my jobs was to, do all the concrete testing. And so does the technology today and the sensor installations, could that potentially negate the need to take these cubes, slump tests, and send to laboratories in local universities and so on to get results back? Is it possible to do all that in real time?
I mean, all the data is gathered right in real time in the cloud. And what we often see is that, before you're used to maybe do, 1 day specimen, 3 days, 7 day, 2 week specimens, and so on. You did a lot of specimens, and every, time stamp you might have to do 2 specimens in order to control right. And what we see is that all clients move more to embedding sensors, right, and follow that as your trends or your curve. And when the sensor says, "Hey, now time is right," you can always go and do your one compression test, right, and just to validate that result. So instead of having to do specimens to validate the result, like follow the trends, which is by default difficult when you only do spot measurement, right? To spot any trends, makes a lot more sense to use the sensors for that.
There's a lot of debate at the moment, thank you, Casper, about, industrializing construction, modern methods of construction, factory building. And you mentioned precast companies, and obviously they're trying to get an efficient workflow and utilize resources in the factory before they deliver to site. Are you seeing a lot of precast companies using this technology?
Yeah, I mean, we actually started in the precast. That was our first clients we got there. In Denmark, I think actually 40% of our, concrete casters is precast concrete. So, and I think globally you see a huge, everything relative, but at least the precast industry is for sure growing. The prefab, pre-built. So that's for sure like an efficient way of making the concrete under controlled, relative controlled cycles, but you're still facing seasonal differences from summer to winter concreting. Materials are changing, so you still face challenges, and especially if you want to do like 3 cycles a day, right? It's important to keep your 6-hour production time.
So I'm presuming the sensors can control. You talked about the heating of the beds. It can control. It can switch on and off the supply of that, can't it?
Yes, yeah. I mean, it's in most precasters today, right? There's like one guy coming Monday morning. He might come 4 a.m. He might come 5 a.m. and then he goes on turn on the heating, right? And
so he could stay in his bed and just use his iPhone, no? Just to.
At least we want to make. We want to, make it simple, and sometimes when people are involved, there will be mistakes happen, right? So we see it often that then he suddenly turns on bed number 4, while today they're casting on number 3. So that today they don't have any heatings because he turned on the wrong bed.
Okay, so thank you. That was a great overview. Obviously, a very specialist focus of IoT and smart sensors, but one that wouldn't necessarily think about that you put it into permanent structures. I mean, it just makes sense. Do we have any questions from the audience? I know, I'm not sure if we have any engineers or structural engineers with us, but it maybe before we move on to Rob, if any, or if anyone would like to say something, I see David is there as an architect. David, what do you think of this application for the world of architecture? Is David with us? Sorry, no mic. Okay, that's fine. No problem. I'm sorry for putting you on the spot. So, thank you very much, Casper, and wishing you continued success in your business, and hopefully sometime we might meet in person.
Yes.
Who knows?
Thanks,
so, moving on to Rob. Rob is going to be talking about leading nicely into Rob, actually, the idea of, I suppose, health monitoring, structural health modeling towards networks of predictive twins in the built environment. Rob, over to you.
Yeah, thank you very much. I will share my screen with you. So, can you see it?
Yes, I can. Very good.
Okay. Very good, very good. Well, yeah. Thank you for inviting me, and I think it's a nice build-up presentation modus, because what we just heard, we are implementing those technologies as well. First, it's a pleasure to meet you. I work with TNO, which is the Netherlands Organization for Applied Scientific Research. We are not a typical organization. We are founded by the law. So it's a non-typical research organization. I'm heavily involved in Building Smart International. I'm co-chairing the Building Room, and I'm a board member of the Benelux chapter. Well, so I work with TNO. Let me see if I can see my own screen. Well, TNO occupies a key position in the innovation chain. In the innovation process, the TNO takes various forms and involves various partnerships. Firstly, we work with universities, who are the most important suppliers of fundamental knowledge. Of course, we are traditionally a public knowledge organization, so we develop knowledge in partnership with governments, societies, universities, and WOs. And of course, business, the golden triangle. And knowledge application through contract research is another service that we provide. And last but not least, knowledge transfer is the last step in the innovation circle, in which we want to play a role. And these kind of presentations are part of that. The construction and infrastructure sector faces enormous challenges, I think worldwide, but now I'm speaking about the Netherlands. For example, the infrastructure sector is on the eve of a major replacement and renovation tasks for existing civil infrastructure. Well, we know that we build a bridge with a theoretical lifespan and 50 to 80 years, so the theoretical lifespan is almost over. And the sector is also making a move towards circular construction, and I think that that you all know that we are doing a lot of research to reuse construction materials like concrete. And a widely supported view is that these challenges and the associated adaptations to the built environment can only be realized through the intensive use of advanced digital solutions. I'm having a little bit troubles with my screen here. So we expect that predictive twins will be used to replace and renovate existing civil infrastructure in order to predict the expected technical lifespan. Well, this takes into account, among other things, the obsolescence of civil engineering structures and future changing traffic loads that is constantly changing. And with these insights, maintenance, renovation, and replacement can be optimized at the construction and network level. In the transition to a circular construction sector, predictive twins can function not only as a building material passport, but can also play an important role as a tool for monitoring and forecasting the technical lifespan, the quality of building components, and the behavior and technical lifespan of circular building components and materials. In new circular structures can be better demonstrated, giving an important boost to circular construction. We have a couple of focus points within my cluster at TNO. One is the smart measuring systems, and we are using them. We're looking at behavior and the condition of structures, and those are monitored by digital technologies such as sensoring and drones as well. ALIM, we call it, is Asset Lifecycle Information Modeling. That's semantic linked data that includes the concept and technology for linking different data and data structures over the entire lifecycle of assets. Linked data is an innovative concept for linking different data files and information structures. Furthermore, we use artificial intelligence and machine learning to interpret data, eliminate errors, and optimize designs. And the predictive twins is where that all comes together. Well, we all know that BIM has various meanings. In the beginning of this century, we see more and more applications of BIM working with 3D models consisting of 3D objects and the related information about those objects. And we see architects, engineers, construction companies, subcontractors actively working on the introduction and the application of BIM. So I think BIM is one of the first steps into the so the building information modeling is one of the first steps towards predictive twins. As I said, asset lifecycle information modeling plays an important role. And it's not surprising that the use of BIM is lagging behind in the management and maintenance phase of construction work. Well, we often see it in the programming and the design and engineering, in the realization, but the maintaining phase, the actual use of the structure is very important. And in that phase, we must combine BIM data from the design and realization phases of the structures. And many buildings were built years ago, and no BIM data is often available to these buildings from the design and construction phases. So initially, BIM was mainly about making 3D models of structures. Nowadays, we see that 3D models and 3D objects are becoming less central in the BIM development. Increasingly, it's about linking all kinds of data during the life cycle of building in all kinds of formats. Data sources are captured. We saw that already with cameras and drones. And well, all those data sources need to be combined. So a building information model is often associated with a 3D model. And that's why more and more people are talking about building information management. And that's more the object-oriented recording, sharing, and management of building information throughout the entire life cycle of the construction of a building. What we are seeing is more and more that there's more and more data available that we can potentially use to make better decisions. And those measuring systems, data sources. As an example, you see on the bottom left corner the Van Brienenoordbrug. And we assess their various data. We have the weather data, traffic data, measurement data of the bridge. What we see is self-measurement. That's what we do as well. We do traffic load and stresses in the bridge. We measure that with sensoring. And we have actually sensors that are listening to the quality of the weld of the steel construction. And if you combine that all, well, then we are going towards those predictive twins. And we go then from measuring to forecasting. That's the realm of the predictive twin. So what do we understand by a predictive twin? That's a digital replica of a structure, such as a bridge, but it can be a building as well, but I only had 20 minutes. Or a composition of assets. A predictive twin assesses the actual state of his physical twin, of his physical state. And a predictive twin can always make predictions about the behavior of the physical twin. As well, and that's a very important new element, a predictive twin continuously learns from the information it receives. And finally, a digital twin makes proposals for certain decisions. And we foresee that in the future, a digital twin can even make decisions for its physical twin. We can do that on different levels. So you see construction level, component level, but network level as well. If we are looking more specifically, we see three components that are needed to be integrated. And that's what we at TNO are doing for years already. First, we see the information component. We call that the ears and the eyes. Those are the measuring data, the building information models. But secondly, we see the model components, which are the actual brains. So we are developing predictive models, part of the predictive twin, and we are creating learning models based on the data received by the predictive twin. We use machine learning techniques to recognize patterns in data. And finally, we see the simulate and decide component, which you can compare with buttons or gauges. Here, future situations can be simulated, allowing predictions to be made and possible scenarios to be assessed. And we are active on each of these components. And we are now also taking steps into the integration of this. We do that at those various levels. Like I said, we do it on a component, object, structure, build environment. And I'm going a little bit more in depth there. Here you see the Van Brienenoordbrug again. We took a step last year with a predictive twin for critical bridge stack, in which the components mentioned are applied together. So it's one of our field labs, actually. Essential here was to get a better insight into the current and future condition of a specific critical bridge component. So in this way, maintenance and replacement can be planned cost efficiently and with as little inconvenience as possible. So we have developed a predictive calculation model for the bridge, for the bridge deck. In this model, all kinds of information are included, such as year of construction, traffic load, temperature changes, dimensions of component, structure, and amongst other things, the stresses in the bridge deck can be predicted with this model. By linking this model to a crack growth model, predictions can be made about the occurrence of cracks in the bridge deck and therefore damage to this component. Here you see the schema for that. And like I said, we do that on various levels. So we do that on component level. We can do it for the overall construction. And what you see on the right-hand side is platooning of trucks. That's the trucks that driving with the same speed, with the same distance, controlled by monitoring. And we can even predict what platooning, what impact platooning has on the bridge. But we can do it on a network level as well. We do a lot of measurement throughout our road infrastructure. We call that the project TNO Load Map, where we can we can see what the impact is if a certain construction is under maintenance. I'm already on the end of my short presentation, but not before I would mention a couple of conditions intelligence coming towards those predictive twins. It needs to be fit for purpose. So we don't need all data. I always say that BIM is a demand-driven process. So you need to deliver the information to someone else so they can do the job better. And it's the same with predictive twins. Big data is sometimes overwhelming. So really fit for purpose. One other very important thing is that we need to integrate knowledge domains. So of course we need to have knowledge of civil engineering, but artificial intelligence as well, information modeling, open standards, and of course the different interests are very fragmented, but that's very common in the construction industry. That everybody has different models, and we think that owners like Rijkswaterstaat, our road authority, is really the driver behind these kind of behind these developments. We introduced, or we published a paper last year, end of last year. It's now translated into English. It's not published yet on our website, but I can share it through CitA if you are interested. I can share it with Ellen, so Ellen can share it. And
thank you, Rob.
Yeah, this is well. If you want to reach me, this is my email, Twitter and LinkedIn, and of course I'm always here to.
Thanks, Rob. That's excellent. Thanks for the overview there of predictive twins. I actually had a quick look at that report.
Yeah.
And at the very first page, actually, the contents, it said, BIM is a stepping stone to predictive twins.
Yes, correct.
Can you just elaborate on that?
Yeah.
They say they should coexist. You know?
Excuse me?
They say that the digital twin and the physical twin coexist.
Coexist.
So, so if you have like a design model or a construction model, it doesn't generally get passed on to the FM team, the people managing.
Yeah.
So what relationship does BIM have to digital twins and predictive twins?
You can
and what role sensors play? Sorry.
Well, we did a lot of simulations in the with buildings as well, where we actually don't use a building information model, but we use a building energy model. So that's derived from a BIM, where we can combine sensors to the flow of the temperatures, for instance. And I know, Ellen, that we don't have often as-built models from the actual constructions. I always call them as promised. So that is the fit for purpose. So we only need that kind of information that we need to predict the remaining life cycle of a construction. So we don't need the complete BIM model of the bridge.
No, I agree but it's interesting if you talk about circularity, and I mentioned earlier on about the circular economy series we're running. It's if we take make and waste, this is the linear approach. If you create all this design information, construction information, and then you don't pass it on to the people who maintain, it seems to be a waste, does it not? I don't know if anyone wants to come in there on that, or Rob, comment on that. Do we have any questions for?
Yeah.
Yes, Natalia.
I was thinking I would like to comment shortly on this. Of course, what Rob is doing is definitely more advanced on the maintenance side, but how we are seeing it at Evercam and how I see it personally is that we are not learning throughout each of the processes. We should be taking more experience from one process and transferring it on to the other, like the continuous learning. The cycle is broken somewhere. So you see that your BIM model is working up to a point, then you see a delay, but we have so much data and so much possibility to collect this data from each and every construction site to as if feed it back into the cycle and see what obstructed us, what helped us, what would help us next time. Yeah, so I'm thinking also that what we are trying to do.
Yeah, especially for those infrastructure
with this constant recording and integrating all kinds of sensors is a way to facilitate this continuous learning.
Yes, Rob, you were going to come in there about infrastructure.
No. Well, I was thinking that we use a lot of finite element software, of course. We are making analysis there as well, and normally we use those models to predict the remaining life cycle, and sometimes it can take up to a year. But now with the sensoring data, combining those models, we brought it back to a week or so. So actually we don't use the BIM models there.
No, because it's not the information that you need. It's
correct.
Yeah. I mean, it's similar for even construction assets where you have a building management system, and you've designed, built the facility. We've heard in the past from facility managers that they cannot use the information in the format provided to help maintain the asset. So it just seems to me that there's as you were saying, Natalia, there's a disconnect there, And actually, it's interesting the work that Evercam do in placing cameras on physical sites that are being built. Have you any experience of those cameras staying there when the building is being lived in? I mean, is there, has that occurred?
Mm-hmm. This would involve, I'm afraid, the further implications concerning, privacy and people, etc. So I think this would be much more complicated. Yeah, but having the recordings and being able to go back to them, there is an enormous possibility of seeing what's actually inside the building. Yeah, what was done there in certain moments at certain points. Also later when it's already staying, when it's already being fitted out, etc.
Yeah. Okay. Any other questions? We're just approaching 10:02. We may finish early if we don't have any questions, but I did hear, was it Vinny or was it Natalia? Because you have all this coverage and this content, can it be used I presume in a kind of dispute situation? in a negative way, or in a kind of a way to solve disputes?
Oh yes, very, very much so. So we see a lot that the disputes simply don't happen if you have the coverage, if you have the records, if you.
So you don't need to pay for expensive lawyers if you have it all on.
It's easy to see. Yeah, this person says I did it. This person said I didn't do it. It's recorded here. Whoever did it, it's quite clear. So we're seeing also a more collaborative spirit with contractors sharing the camera view with subcontractors, and they simply know, okay, this is happening. We can arrive. We were delayed for some reason. Everything is out there in the open.
Yeah,
and I think it promotes a collaborative spirit, as I said.
Okay. Do we have any other, thanks Natalia, any other questions before we wrap up? Okay, can I just ask maybe one other question, and I can open it up to the floor, or maybe Rob or Casper can come in also. They say that BIM plus sensor technologies can create digital twins. I know was it mentioned, maybe it was mentioned in another meeting I was at recently about this, the Edge building in Amsterdam. Rob, do you know this building?
Yes.
Yeah, it's reputed to be the smartest building in the world.
Yeah.
They would say that, wouldn't they? What? This is a building that has sensors.
I know, and it has face recognition when you enter and those kind of things. Yeah.
Have you heard this? This building is the smartest building in the world.
Yeah, I've heard it. I've been there. Yeah.
Do you believe it?
I don't know. I was in the Microsoft office as well. That's a very smart building as well. So.
Yeah, but I guess the real estate sector is now starting to see the power of digital twins. Exactly. In particularly, you might have heard of Matterport technology, where they generate all these brochures and so on. But now that clients cannot visit buildings, or they want to market buildings, camera technology, sensor technology, smart technology connected to BIM data can create intelligent buildings.
Yeah. Well, like I said, I think that owners are very important here. So if owners see the advantage, then, well, they can be the catalyst there.
That's right. So listen, thank you, everyone. I won't keep you much longer. Yes, Natalia.
Oh, sorry. I just wanted to say that there are very many things are possible these days. The question is what is really needed. Yeah.
Yes.
What the users want, what the users need, what will they be using? It's an art to install 1 million sensors, but it's even higher art to be able to draw the data from them.
The data, in a structured way. How do you do with all this information? Okay. Well, thank you, everyone. I'd like to thank everyone, certainly to our three speakers, to Natalia and Casper and Rob, for 3 fascinating insights. I always learn so much at these events. I didn't realize that the cameras that Evercam provide are so versatile and multifunctional. I also was fascinated with Casper's presentation in regard to how you can help companies who construct in the factory or on site, save time, and reduce carbon footprint. And Rob, it just makes such sense for government agencies who are responsible for infrastructure to know and predict how these structures are behaving. And predictive twins is even better than digital twins, no? He's even more intelligent. Well, listen, guys, thank you so much. And so we'll be back again at the end of May, as it the 26th of May, or 22nd of May, looking at drones. And so we should have a lot of interest in that. But we'd like to thank you once again. And to all the team behind the scenes as well for helping out. Thanks, Suzanne.
That's great. Thanks everybody. Great event.
Okay. Talk soon, guys.
Bye.
Take care. Bye.
Thanks, guys. Thanks, Alan.